Tungsten inert gas welding. So in this video we are going to study about the second very important type of arc welding apart from MIG welding, that is TIG welding. This is Dr. Gurraj Singh. This lecture is going to be split up into 6 portions, which begins with a basic introduction to TIG welding, followed by the description of the process that is followed to perform it. Then we will learn about some of the equipment that are used in this process, especially the nozzle and the power source. And finally, we will be ending the lecture with the basic knowledge of the advantages, disadvantages, and the applications of TIG welding. So what is TIG welding? TIG welding, which is also called as Tungsten Inert Gas Welding, and there's another name for it, Gas Tungsten Arc Welding. So both TIG and GTAW, they refer to the same welding process that uses a tungsten electrode. Now the name TIG, Tungsten Inert Gas, or Gas Tungsten Arc Welding, both of these names, they have their 3 basic keywords: tungsten, gas, and arc welding. So each of these words has a very important meaning in the actual process that is performed for making the welds using this process. Arc welding, well, that clearly shows that it's an arc welding process. It uses an electric arc to perform the welding process. Tungsten clearly signifies that the electrode that is used in this process is made up of tungsten, while using the term gas or inert gas means that we are using a shielding gas for the shielding operations as used in MIG. Now, why do we refer to MIG as metal inert gas? Because in case of MIG welding, we do not use a filler metal. Instead, the metal that we use as an electrode is a consumable metal and is of the same material as the base metal. So therefore, the same metal is always used. For example, if you're trying to weld copper, you'll be preferably using a copper electrode. And as a result, it is called as a general name, that is metal inert gas welding. But the name tungsten inert gas welding is a very specific name, and always an electrode made up of tungsten would be used. And the significance of using tungsten is that it is a refractory metal, it can withstand high temperatures, and it is used in those processes where we do not want the electrode to be consumed. So it is a non-consumable electrode. So it is a strategy that involves the usage of a tungsten electrode to heat the metal that is being welded. And to protect the weld from contamination, we use shielding gases. We've already studied details of shielding gases and the mix of shielding gases that can be used. The process can be applied to more metals than any other method and is capable of welding metals like steel, bronze, nickel, brass, copper, magnesium, aluminium, as well as gold. So you can see that this process is suitable for welding a whole wide range of metals, and that's where its importance lies. Welding in a TIG operation is very precise and clean, allowing for a superior appearance because a welder can increase and reduce the amount of heat in the process. Now, the increasing and reducing of the heat in this case is because tungsten can withstand that heat. You cannot do the same in a MIG welding setup because the metal will only withstand heat for a certain level, but beyond that, it will not. So therefore, this is the advantage of using TIG welding. Also, if you can see this diagram, you can clearly visualize that you kept the electrode on a negative polarity while the workpiece on a positive polarity. So this type of polarity is also called as DCEN, direct current electrode negative, or it is called as straight polarity. Straight polarity. So the reason for using this is because you do not want the electrode to be consumed. You want it to remain cooler as compared to the base metal. And therefore, we are already aware that 2/3 of the heat is always going to be evolved on the anode, while 1/3 is always evolved on the cathode. So you've kept your electrode connected to the cathode so that it has to withstand lesser heat, and as a result you can increase the life of your electrode. This is the setup of a TIG welding equipment apparatus. So you have a source for supplying the inert gas. You have a power source. Then you have the power source which is connected to the TIG torch. Now this TIG torch, since you want to keep it cooled, it is always connected to a coolant system, and it may be air or water cooled. Then there's a foot pedal that is used for operating your electrode or your process or for supplying the power. And then there's a work cable that is connected. Now what do you think this is connected? Because we are trying to complete the circuit. So by connecting this plug to the workpiece, we are completing the circuit, and hence we are performing the weld. So in the TIG welding process, the arc is formed between a pointed tungsten electrode and the workpiece, and in the atmosphere of an inert gas or a mixture of inert gases, probably argon and helium. High intensity arc is produced between the electrode and the workpiece, and the TIG welding, the workpiece is connected to the positive terminal and the electrode is connected to the negative terminal. This we've already discussed in the previous slide. And the arc produces massive heat which is used to join the plate, and the shielding gas is used so that it prevents the surface from any sort of oxidation. Now when I talk about the other parameters, so in the process low voltage and high current is supplied by the power source. So you always preferably use low voltage and high current. And the supplied current, it forms a spark between the tungsten electrode and the workpiece. And tungsten, since it is a non-consumable electrode, it gives a high intensity arc. So the intensity of this arc is very high since it is a non-consumable electrode. And it produces intense heat and melts the base metal. In this image, you can see that there's an effort to actually automate the setup. So you see the power source is similar, the gas supply is there, the nozzle is again similar, but it is held on a setup that is automated. So this setup, you can automate the process, and this is how the modern industry, especially the automotive industry, is using TIG welding process, by automating it. So automation can be easily applied, and that's another advantage of this process. Now when I focus upon the TIG welding torch, so the TIG welding torch, it has three major components: the collet, the nozzle, and the tungsten electrode. So these are the three main components of your pointed tungsten electrode, and the functions of each are pretty much already known. That the collet is used for holding the electrode, and the nozzle, well, it assists in formation of a firm jet of the inert gas. So that's what the nozzle is used for the shielding purpose. And the flow rate of the shielding gas, it may vary from 5 to 50 liters per minute. So it's a highly variable rate, and you can supply it on the basis of your need. And depending upon the current carrying capacity, the welding torch can either be water or air cooled. So these are the important components of the welding torch. That's how the torch actually looks like. So this torch is very much different from what we saw in the previous lecture to how a MIG torch looks like. It is more of a bent torch, but this one is more of a pointed torch, and the reason for this is because this has a fixed tungsten electrode, while the MIG torch is bent because you've got to supply a continuous wire spool and you've got to feed it as a consumable electrode. Now we'll discuss something about the power source. So first of all, the voltage range is going to be between 10 to 35 volts, while the current is going to range between 3200 to 5300 amperes. So these are the two most important parameters in any arc welding process that decide the quality of your weld and the properties as well. Tungsten electrode, it has a DC-SP polarity, so that we've already discussed previously, that it uses a straight polarity, or it is also called as a DCEN polarity, which is direct current electrode negative, where the electrode is connected to the negative terminal. And although DCRP and AC polarities can also be used, Now, obviously, you can use any polarity, you will get the welding results. But in case of the DCEN polarity, you will get the best results. Additionally, if you add 1 to 2% of zirconium or thorium to the tungsten electrode, that improves the electron emission capability, the arc stability, and increases the melting point of tungsten. That is also called as wolfram. This is the symbol for tungsten, a W. So, addition of zirconium and thorium is promoted. Then the TIG welding with DCRP is preferred for welding reactive metals like aluminium to take advantage of the cleaning action. This cleaning action is also called as cathode cleaning. So this is where you can use a reverse polarity. And a straight polarity that we generally use is used for welding metals such as carbon steel that don't require much cleaning. Now, what are the advantages of TIG welding process? Well, it provides a much stronger joint when compared to the shielded metal arc welding, which is the basic form of arc welding. The joint made with TIG welding is corrosion resistant and ductile. So that's a very important point to note here. In this welding, a variety of joint designs can be formed. This welding type doesn't require flux, so you do not require any sort of flux in this case. The process is easily automated and it is suitable for thin sheets as well. And it provides excellent surface finish as there is no metal spatter. The flawless joint can be created due to a non-consumable electrode, and a welder has more control over welding than on the other welding types. So this is a much easily controllable process, and it works with both AC as well as DC that we've seen in the previous slide, that it can be used with different types of polarities. Now, if we talk about the disadvantages, it can weld up to a thickness of 5 mm, and it is not suitable for welding very thin metals, that is, metals beyond this thickness. It cannot be used for reactive metals like aluminium and titanium. It requires a very high skill labor. It has an initial or a very high setup cost, and it is a slow welding process. So these are some of the disadvantages of tungsten inert gas welding. Now when I talk about your applications, well, it has, just like in case of MIG welding, it has applications in all the important fields like aerospace, automotive industry, then for the repair work that is performed, and also in case of artwork, because it has a very superior cosmetic appearance. So for all the artistic works as well, it is always preferably used. So this is all about tungsten inert gas welding, and in the next lecture we'll be starting with submerged arc welding. Thank you.